I appreciate the opportunity to come and speak as the new CEO of On-Ramp Wireless. It's interesting talking about low power, wide area. I titled this one Low Power, High Return. It's an interesting space. And where On-Ramp sits is in a unique place that we believe is actually between low power wide area and the cellular companies in the vast middle land here. And I'll talk about that in a little bit here. But the bottom line is the low power part of this and wide area part of this network and this technology that is evolving today as we speak, and we're starting to hear a lot of buzz about, is becoming a bigger buzz and a bigger situation because of what is happening in the cellular industry. If you look at what has happened here for M2M and IoT connectivity, all of us in this space, we've just been this little bird on the back of the hippo. It's a great working relationship. I don't know if you know about these birds on the hippos, but the hippos let them stay there because they pick all the little pieces and parts and gnats and stuff off the hippos. But what's happening is in the carrier world, the engineering, everything that we're doing, and the generational effect of 2G, 3G, 4G, and 5G coming and so forth is creating a larger and larger disparity between what we need in this machine world, in this Internet of Things, and what the cellular companies are doing. I mean, we need them to go bigger, faster, better, and with every generation. We want more stuff on here. And if you look at the technology that started all this, whether it was CDMA or GSM, it was all about human interface. And what we're all here talking about is machine interface. Now, sometimes these machines are going to be interfacing with human beings, like a parking meter or other things we'll talk about. But the bottom line is the networks that were built on the cellular technology are built for humans. There needs to be technology that's focused on machines. So if you look at what's happened in the evolution of the technologies that we have today, there are all these different vertical segments that have grown up over the last few years. And some of them have really started to explode. As you look down here, you have different segments in energy management, transportation, and automotive. Some of these have become very, very large verticals because the cellular pricing has gotten where it needs to be. The cellular technology matches up with the needs very well. The challenge is we've got tens of millions of 2G devices in the U.S. today and many more than that throughout the world that are going to be sunsetted out. And that starts to create a dichotomy with just about the time we're starting to reach an inflection point with M2M and IoT where it's all starting to gather all this momentum. We're going to pull the rug right out from under it. And it's not that the carriers want to do this. They have limited spectrum. They have to do what they have to do. If they could, they would leave 2G alive forever. But they can't. And they're not going to leave 3G alive forever. And it creates major challenges for our marketplace at just the wrong time. So as we start to look at what's happening, the carriers have to focus on their core business. Makes sense, right? You look at the ARPU differentiation between what we're doing with machines and what's happening in the cellular world, and what the investors on the cellular side that are buying stock in these nice big public companies like Verizon and AT&T, Sprint and T-Mobile and others, as they're doing that, they're still focusing on that ARPU. They still ask. You go to the quarterly analyst briefings, they still ask about ARPU. And obviously ARPU in our industry is meaningless, because it's not about how much you're going to get out of each device. It's about the total volume of the overall marketplace. The other thing that's happening, if I could push the button right here, is you're seeing this major disparity of what's happening with every evolution of cellular versus what the machines want and need. I keep hearing, and I've heard it over and over again, well, we got to go to 3G, we got to go to LTE. All these applications are going to use so much data. Well, some of them are. But when there's going to be tens of billions and hundreds of billions of machines out there, there isn't going to be tens of billions and hundreds of billions of machines using tons of data. There's going to be still this massive disparity between what you need for a machine and what you need for the human interface. And the disparity is getting greater with every generation of cellular. This is basically what the difference is if you look average data rate per user on machines versus the humans' devices today. So, what are we doing? We are telling everybody, hey, this is going to work great for you. You want a drink of water? Well, here's what you get. This is one of the guys that works for me, one of his daughters. And she said, all I want is a drink of water. But what's she getting? It's like, please, take all this, take all this. No, open your mouth and take it. LTE is the answer to everything. But I only need 5 bites. Oh no, LTE, it's everything. No, it's going to be there. It's going to be there for a while. That's part of the key. So what's happening is it's just this unrealistic level of expectation. So what needed to happen is we needed to have technologies that were created that drive to what the machine ecosystem needs. Cellular sunsetting is a fact of life. We've been through analog sunsetting. We're going through 2G sunsetting, 3G sunsetting's right around the corner. Someday there will be LTE sunsetting. We're talking about 5G standards as we speak, and even rumblings about what 6G may look like. This is not user-friendly in the machine world. The other thing is signal penetration on the cellular side is really good for the vast majority of what we do, but we've all been in parking garages where it doesn't work, or other places where you can't get penetration. Does anybody know what time of year you get the best coverage on cellular networks? Say that again? Winter, not summer. Why can't you get good coverage in summer? Leaves. The difference between winter and summer cellular coverage is significant because of leaves. Damn leaves, that's right. So it's a big deal. The battery life, we all know about battery life, right? I mean, how many of us have killed our phones in a day? How many times have we tried to create applications where we really do want to come from a different power source for our machines because we just can't get a realistic battery life to be able to support the models that we're trying to create. We're talking about putting devices out there that we want to be out there for a very long time, and we don't want to touch them again. But cellular battery life is a pain point. Remote coverage. We're never going to cover every inch of the United States with cell phone towers. About 25% of the U.S. today on acreage doesn't have cellular coverage. It just doesn't make financial sense. And if I were running a cellular company, I would never, ever put a tower where there's going to be a few sensors for agriculture or water management or energy management or whatever if you don't have all these people with this nice ARPU. It just, the mathematics don't work. Data rounding. Interesting thing in billing. Anybody that isn't familiar with this, get familiar. It's a big deal. And finally, network costs. The overall network costs of running a cellular network are huge. We all know it, the amount of money they have to spend on spectrum, the amount of towers that they have to put in place in order to get the coverage that they need. Network costs are astronomical. You take the cost of what we build. We've built networks all over the world on 5 continents. We know how to build them. We know how to run them. What costs me $25,000, in the best case scenario on a cellular side will cost $2 million. Usually it's $6 million for the same footprint. Completely different model. And it changes everything. So, low power, wide area. It pretty much is built for machines. I would say, I can't say too much because we have a big announcement coming out that will disclose a lot more information in September at CTIA. But low power wide area, it solves the coverage problem. On our network, the maximum coverage we can get out of a tower is 200 square miles. One tower, 200 square miles. Now, that's a perfect scenario, but we have a tower, for instance, in downtown LA for Edison, and it covers 30 square miles of Los Angeles and penetrates every building in that footprint. One tower. You'll never get that with cellular. The technology cannot do it, not within the laws of physics. Battery life. What if you could put a 10-year battery life on every device you put out there that's tracking? You could ping that device 5 times a week for 10 years and never kill the battery. Would that change your business model? Would that change your maintenance, your truck rolls? everything that you have to do with the infrastructure that you have if you could get a 10-year battery life. Additionally, a network commitment. OnRamp is in a unique position in this space because we own all the IP. We were started by the same guys that started Qualcomm. I have members of my board who were the founders and created the first chipset for Qualcomm. They understood the challenges with a fractured ecosystem. We own all the IP from soup to nuts, tower, device, and everything. No one could ever come to us and sunset us out of the business. No one can ever come to us and end of life us out of a product. Ever. We control the ecosystem. We've already upgraded the network and enhanced the network in certain ways that create better benefits to our customers. It's all done remotely, and everything that's historically on there is upgraded along with it. Absolutely no sunsetting. Can you imagine if you could go out there and know that you had a 10, 20, or more year network guarantee? It's one of the advantages of the space we're talking about. Now I'll just show you some case studies of some things that we have specifically built at OnRamp. I don't know if anybody's been to Aruba. Nice island. It's not huge. Pretty good size, though. What do they need? They needed to implement an advanced metering, so an AMI system. Cellular was just too expensive. They just couldn't make it work. And they wanted to have multi-application abilities with this network over time. So what did they get? We built an OnRamp RPMA network, which is our technology. We enabled GE meters. We have GE as our partner in all of our AMI projects. Only 8 access points, which are towers, cover the entire island. Every meter in the island, including meters that are underground. 8 access points. Their initial application was for AMI, but once they got it up and built, they realized they could start running multiple other services, products, and applications on it. Now it's a multi-purpose network for them. So, let's see. Go to my next case study here. So, WellAware. This is an interesting one. You know, there's not a lot of coverage in the oil patch. It's one of the challenges that I faced throughout my career being on the cellular side of this business, of being able to cover everything for an oil company. Chevron was one of our customers in the past, and other large oil companies. And we could always cover this much of what they had. But there was this other big part that we could never get coverage to. And the challenge is, you know, satellite's expensive. We had satellite partners, but it's expensive. And cellular is cost prohibitive besides the challenge with coverage. What WellAware's been able to do is they've already connected over 55,000 square miles. They'll be over 100,000 square miles within a few months here. And at that point, they will have covered almost 90% of U.S. oil and gas production with the network that they have partnered with us on. So what have they been able to do there? They lowered their CapEx, they lowered their OpEx. They were able to get all this connectivity to every piece of their infrastructure. And what the benefit was to them ultimately is we gave them the biggest coverage footprint they could possibly have, lower cost of deployment, and it's purpose-built to meet their needs. So that's what we can do in this space that's non-cellular. One of the other things that really works well in this technology is the fact that it's not cellular. I don't know how many times you guys have been at a football game or a baseball game or whatever, and you can't get out. You can't get a connection because you're bogged down in that cell. You're stuck in that cell. Well, with RPMA technology, I could have a tower 20 towers away on a mountain 60 miles away, and my device will keep looking and looking and looking until it finds that tower. There's no cell involved. There's no restriction geographically to where I am. I can keep going and going and going. And it's interesting because San Diego County, for instance, we cover every square inch of San Diego County. For SDG&E, we can get every underground gas and electric and water meter they have, even in basements of buildings. Covers everything. And we put a tower on the top of Mount Soledad, which is the tallest mountain in San Diego, and that thing gets pinged every once in a while. When the network getting a lot of hit in one particular area, some device literally 50, 60 miles away will pick up on that tower and still get the connectivity. The advantage of being out of the cellular infrastructure and the constraints of that. So now, when someone says, all I want is a drink of water, they can get a drink of water. You want to use 10 bytes? You can use 10 bytes. There's no data rounding. There is no huge amount of overhead in a packet of data. You just use the data you need, and you pay for the data you need. We have seen companies that have migrated from cellular to our RPMA technology, and their data usage went down by 80%. Even though they got the exact information back, the exact quantity of data back, but their usage went down by 80%. It changes the complete dynamic. Again, when you have a network that's built specifically for the purpose of machines to communicate, you can maximize for the machines. So let me say what LPWA can't do. Can't do voice, can't do high-speed data. You know, that's the cellular sweet spot, and they will own that forever because that's what they do, and they do it well. But the vast majority of the machines that we all talk about and support and the applications that we look at, they don't need vast amounts of data. If you have a device that's using 1 megabyte today, it might only use 200 kilobytes on an RPMA network. If you have a device that's using 5 megabytes, it might only use 1 megabyte. That's not a lot of data. If you have a device that's streaming video, use LTE. You have a high-end vehicle fleet management dispatch with voice and high-end data requirements, LTE is the perfect solution. But if you want to put a tracker on a container and have it run around the country for the next 10 years and never touch it again, then we have a solution for you. You want to put anything out there anywhere and make sure that that device is still going to be able to communicate with a network years and decades down the road, then this is the answer. And again, in the unique case of OnRamp, we own all of our IP. The guys that started the chipsets at Qualcomm a few years later specifically set out to say, okay, we've built this huge industry out here. What's next? What's machines? They knew what they built. They knew exactly all the strengths of what's now LTE with the convergence of GSM and CDMA, but all the strengths of what they built for this human interface. But everything that makes those things strong has a tendency to have a counterintuitive effect on what we're trying to do for the machines. So that's why they set out to do the RPMA technology. So I believe that low power wide area is a solution to the vast majority of the machines, and obviously I think my technology will be the leader in that space. But the basic thing is there needs to be an alternative, and the companies that are in this space do provide an alternative. And thank you very much.